everybody, welcome back. In this tutorial we are going to cover some pretty cool stuff with Pyro and how to evect particles with it. It should be a nice, quick, and easy tutorial with a really nice result. Let's go ahead and get started. Okay, here we are in Houdini, just our normal setup here. So what we need to do is, what we're going to be doing is what's called advection. Um, and I covered this in one of the other videos where we were doing advection with Pyro and Vellum. But for this one, we're going to do it with particles and create a pretty cool effect. So as usual, we'll just go ahead and create a geometry node. We'll just call this trails, jump inside. So first thing we need is a source for the Pyro. So just a simple kind of Pyro simulation. So let's go ahead and start off with a sphere. And we'll just throw a transform down. And let's go ahead and change this to polygon and frequency up to 10. And let's go ahead and move this up. And our Y, we'll just move it up. We just need some space for the smoke to go. So we'll just say about there. Should be good enough. So next up, we need some velocity for this. So we're going to go ahead and do a point velocity. And plug this in. And we're not going to do curl noise or anything like that, or you could if you wanted to. But for now, we're just going to add some velocity, and we'll just set this to -15. Then next up, we're just going to go ahead and do our Pyro source. Pretty easy. So Pyro source, and we get this. And let's go ahead and initialize this to source smoke, which gives us density and temperature, which is what we want. Particle scale and separation, these are fine as is. So next up, to see these points or to see our smoke simulation, we need to rasterize it. So let's go ahead and do a volume rasterize attributes. Plug that in. We'll go ahead and mess with a few of these settings here. So we have attributes that we want from this, right? So we have those density and temperature attributes. We want to definitely get those. So under our attributes, you see we've got all of these listed. So let's just take the density, the temperature, the velocity, and the P scale. We'll take all of those. So now we're going to get this. Hit play, nothing happens because we don't have a solver yet. So let's go ahead and make one. So we'll go ahead and lay down our Pyro solver. And set this up here. So a few things we want to do. Let's see here. So what we can do instead of using a collision object is we can just set this bounds here. So in our bounds, if we go to boundary conditions, we'll just treat Y and we'll just do a closed below. And that'll just basically stop at our ground plane. Let's go ahead and see what we get with just the defaults here. There we go, got our simulation. But what we want with this effect is kind of like the smoke should kind of stick to the ground and not fly up with buoyancy like that. So for this, let's go ahead and start going into our shapes. So our buoyancy is definitely one of the first things we want to do. Let's set that to 0.2 and roll this down. I think everything else should be okay as defaults. And then let's add in some turbulence. Set that to 0.1. Shredding. Set this to 0.2. And these are just values I'm just using for testing. Let's see what we get. There we go. It's nice. So it's it's dissipating pretty nice, but I think we may want it to be a little bit quicker than that. And we're also getting a constant source here. So we want to go ahead and set that up so it's not just constantly spitting at us. And to go ahead and make this thing, so make this pyrosome so it's not just constantly putting out smoke, let's go ahead and jump back to our pyro source, and we're going to animate a few things here. So I'm going to turn this little brain off down here so we can work without it simulating, and then jump up here to these values in our density and temperature. So let's go ahead and just set some keyframes for these real quick. Let's go ahead and make sure everything's at 1 in the start. So I'm just going to hit Alt left click for these 4 values, and then go, I don't know, maybe a second in to about here, and we'll go ahead and set those values again. And then let's set it to fall off, say over the next second or so, and we'll just set all these to 0. And I'm sure there's probably other ways to do what I'm doing, but this seemed the most straightforward and direct way to get the effect that I'm looking for. So now let's play this back and see what we get. We should get a nice fall off to where it disappears. And that is what we want. So it's still kind of getting up off the floor a bit much. So let's take a look at pyro here. Maybe our buoyancy might be a little bit too high. Let's set this to like, let's try -5 for this gravity direction. See what we get. That's a little bit better. You know what? Let's just go to like -20 and see what happens. And I'm gonna go ahead and reset this simulation. I think we're getting the same simulation again. Sometimes it needs to happen. There we go. So that's pretty good. We can probably let's just go ahead and cut our buoyancy way down. Say 0.05. That should may make it too heavy, but let's just see. There we go. That works. It's staying where I want it. Alright, so great. So now we've got our pyro. So next up we need to make some particles to advect. So let's go ahead and do that now. So let's go ahead and just drop down a tube, and we'll do end caps. And I'm just gonna share our volume over here just so I can have an idea of where I want the scale. So definitely bring the height down and scale to like 3. That should give us enough. And then rows and the columns, I'm just going to crank that up just so it doesn't create any weird shape. Drop down a match size, get it onto the floor. Like so. And then we're going to do a points from volume. And what this will do is create a volume of points for us to advect. This is a little bit even, so honestly this doesn't matter because we're not really going to see this shape, but we could just make this look a little bit better. And as far as how many points, we'll crank it up here and see how many we get, or how many that we're going to use. Source, all this stuff should be fine. And now we should just see a bunch of particles, which we do. Alright, so now we've got points to advect, and we have our advection pyro. So let's just create some nulls just to keep things tidy. And we'll just call this points. Call this pyro. And next up, we're just going to create a pop net. So let's go ahead and do that. Pop network. Let's dial these in. And next up, let's go ahead and jump into this pop net. Okay, let's jump in here. And this is a pretty easy pop net that we'll be setting up. So let's go ahead and just give us some room here. So the key node that we need is our pop advect from 5 volumes. This is what's going to give us the cool look that we're kind of looking for here. Couple things let's update. So let's go ahead and change the advection type here to update velocity. Fel is fine. And then for our stop input, the actual source here, let's go ahead and use our second context. And I think that should be about it. These things are fine. So let's see what we get from this. Okay, in our source tab, let's go ahead and change these settings for a type admission. We just want to use all points. And our geometry source is our first context geometry that we have plugged in out here, which is our points. And that should just about do it. Let's look at our other. We want to go ahead and this impulse activation. Let's go ahead and set this to just frame 1. So this will give us just a burst, and then that'll be that. And life expectancy we can change. We can keep the same. So this, just to reiterate, this impulse activation. So when it equals frame 1, then we'll impulse. After that, it won't. So we should start to see something like so. So as you can see, what we're getting is our particles are being pushed around by our pyrosim. So what we can do with this, let's go back up and let's just go ahead and get a few more points in here. Let's see. Raise up our density quite a bit. Let's just go to 20. Get crazy. There we go. And that looks super cool. Just zoom out so we can see the whole effect here. So obviously you can mess with your pyrosim to get all kinds of different shapes and the like. You can see here, we have this nice shape at the end. Super cool. So I think one thing we may need to do here is lower the life expectancy, because our pyrosim, if we look at our pyro here, all of it's pretty much gone by frame 80. So we need to make sure that our particles are dead before that. So let's go ahead and go into our popnet here. So I think the issue here is just the life expectancy. I think I've just got this turned up way too high, so let's just turn this down a bit. I'm just trying to make this as quick as a simulation as possible so you guys don't have to sit here and watch this. That looks pretty good, maybe a little bit longer. That should be enough for what we're trying to do. Good enough. Let's bump that variance up some more. I think this will probably do it for us for the sim. Yep, great. So now we've got these two branches together into this pop net. So let's take a look at what we got. So now we've got some great particles moving and swirling around. So what can we do with this? And it's got this really nice effect here in the middle. It's like where it spreads out, which is really interesting and cool. So what we can do with this is we can make some cool kind of like swirly, curvy particle trails, like curves. So let's go ahead and set that up. So first up, let's just go ahead and set up a trail. And this will create little trails behind our particles. Let's set the length to 30. And I'm just literally just experimenting with this. We'll see what happens. Important result type up here, you want to connect as polygons. And then uncheck closed rows. And you'll see that'll give us these nice curves. So obviously we've got way too many particles now. Or maybe not. Maybe we'll just do it this way. Almost looks like ice growing. Yeah, okay, that's going to be too many particles for us. So let's go back into our points from volume here. And let's lower this down to 10. And then let's see what we get. Still probably too much. Let's try 5. I think this will work for us. Okay, I think what we need to do here, I'm not sure what's happening, but this connect, for some reason this connect as polygons is not working. So we're going to go a different route with this. Same effect, different route. So we'll just go and set this to preserve original, and we're just going to get our points. And then next we're just going to run an add. And this is essentially doing what this trail was supposed to do, but I'm not sure why it's not doing it. But we'll just work around it. So let's go ahead and go back to this frame by groups. Let's go by attribute, and we have an ID attribute that comes from this trail. So now we should see nice curves, and it's falling off the way it should. And it's not turning and flipping out. Not sure why that was happening. But anyways, we'll move on. So what this gives us is these nice curves. And let's just, if we're looking at the points here, these aren't totally laid out exactly how you would want them. So we're just going to resample this. Just to get nice even points. Let's go ahead and go to our length here and just set that to 1.5. So fewer points. And let's go ahead and set this to subdivision curves as well. And let's see what we're getting as far as motion here. Pretty cool. There we go. So one last thing we can do with this is we can go ahead and add some color. So let's go ahead and do an attribute adjust color. Like so. Go up here. Let's go ahead and just set this to bounding box. And let's just say magma. That looks cool. What else can we kind of do with this thing here? I think that's actually going to be that'll be fine. Other pattern types that we can use instead of bounding box, we could use the color attribute. Let's see, we could probably maybe use velocity, might be kind of cool. It's pretty wild. We can use previous. another kind of cool look. There's all kinds of stuff. We could just do random, which will make it down the actual point. You know, let's go ahead and keep it that. Random's pretty neat. See, that might be a little bit too crazy, but let's just see. Okay, that's a little bit too crazy. Let's try remap. Let's just remap. Age. Oh, there we go. That looks pretty cool. Yeah, that's what we want. So this is just using the age of the particle to set the color. We could probably increase this source range just a bit so we don't get all of that kind of beige color. Yeah, there we go. I get that. That's really neat. Liking it. And I think all we need after this is just a poly wire. Just to give it a solid curve look. This is probably going to be way too big. Yeah. So let's go ahead. Since we want the curve to drive the scale of this. We don't want this to be like this whole radius all the way down from start to finish. So what we can do is set over here under our wire radius, we can set this to an attribute, and we can use the curve U that we got from, let's take a second to recalculate probably, that we're going to get from this resample. So we go back up to the resample, and at the bottom of that we're just going to hit curve U to activate that attribute. And now we get this, which is very nice. So let's let this just play out a little bit. I'm going to pause the video, let this run out so you guys can see it. Just 1 second. Alright, here we go. I've just got this play blast here with the finished result. It's shimmering a little bit because we don't have the material set up on this, but you get the point. One of the cool things I really like about this technique is it could honestly be used as a modeling technique, because as you can see, like, this could be kind of an alien flower or something that could actually be pretty interesting. Just as a piece of geometry on its own. So that's it. That just wraps up. Pretty quick and easy tutorial. Obviously you could do all kinds of stuff with the pyro source, with the solver. There's all kinds of things you could do in the popnet. So have some fun, experiment with it, and enjoy. Thanks everybody.